Network cables are important data pathways for us. What do we need to know about them? Find out more next.
You're watching IT Pro TV.
Is a cable just a cable? As a cable? Well, there's only one guy that actually knows, and that's going to be Mr. Wes Bryan here. So Wes, when it comes down to addressing cables, for somebody that's new, this may be a little bit more confusing than we think, and they may grab the wrong cable. So where are we going to begin here?
Well, we're going to do that. We're going to demystify the fact that, well, we don't have one cable to rule them all, if you will. It'd be nice if we have that, but there are different situations in which we might need to recommend a cable. And whether you're going to sit a certification exam, you're going to have to know things like specifications, but also if you're in a support role, it's important to understand, what is the difference between things like copper and fiber, and we're going to address that here in this episode.
All right, I see a whole bunch of cables over at the bench. Why don't we head on over there?
All right, everyone, come on over here and join me where it looks like we are serving up multicolored spaghetti over here. I swear that is not what we're doing. But what we've got is we've got a series of network cables. And if you're going to sit a certification exam, they might put you in a scenario where you might need to be able to identify, one of these many different cable types that we have. And we'll talk about them each individually. One of the first things I want to talk about is really the most prevalent media type, network cable type that we have in the industry today. And it's one that's been around for a very long time. And it's also one that you can see not only in enterprise level networks, but you can see most commonly in residential networks too. And I want to talk about something known as copper-based network media. I'm going to be using that term, so network cables, network media. Keep in mind that these are the cables that we send electrical communications across. And they are really some of the oldest network cables. And we've got a series of standards that we have followed, we follow over the years. Because remember that when we talk about standardization, standardization is a good way that you can easily identify what are the electrical capabilities of the cable. And if you're going to make a recommendation for people, even if you're in a home environment, even if you're in a support environment, maybe you're not sitting the certification exam, that you can understand what are some of those benefits and then what are some of the pros and cons that we might see out of copper media.
Yeah, when it comes down to it though, Wes, today, there really is only one kind of copper cabling that we use for networking. In the past though, we had so many different ones, it would actually be a little bit more challenging to choose. But for us, we really need to focus in on just a few things. What are those going to be?
Well, sure, Ronnie. And that one right there that we have, the most common one, really when it comes to copper media, is going to be something known as a twisted pair cabling. Now, twisted pair cabling, if we look at a close-up view here over on our little cam, it doesn't really look like much, right? We can see, a sheathing, we can see a couple of connectors that we're going to talk about. But ultimately, at the end of the day, it really doesn't look like much. So it's what's inside of that cable that we really need to be able to identify. And when we look at this cable, I've gone ahead and what I've done is I had one of our directors back there in our production team. We've got a bundle of this twisted pair implementation back there. And I said, hey, do you mind grabbing me a piece of this and we can kind of dissect it. So that's what we've done here for you so you can kind of see. And when we look at twisted pair implementations, what you're going to see, ladies and gentlemen, is that you have 8 copper conductors, right? These 8 copper conductors are actually twisted into 4 pairs. Now, certification exam, let's talk a little bit about some of the nomenclature that you might see on the exam. How many twisted pairs do we have? 4. How many twisted conductors do we have? 8, right? So pay attention to the verbiage. And you also want to know that, ladies and gentlemen, honestly, like I said, if you're in a support desk role or, help desk, support desk, and again, depending on what your terminology is there, it is important to understand, just some of the characteristics of these cables. Now, let's talk a little bit about the twists that we see here within this cable here. What do the twists actually do for us, right? You can see there's a bunch of twists, right? And I just kind of untwisted the top so we could see the individual conductors. Well, what those twists do inside of your cable is they allow they increase its immunity to electromagnetic interference. And that's really important. The twists in the cable are actually built that way to help with protecting against electromagnetic interference and any kind of unwanted signal. And there are a couple of different types that we need to be aware of. There are what is known as UTP, and we have what's known as STP. Now, what we're showing you here right now, everyone, this is actually what's known as UTP, all right? U stands for unshielded. And then TP, if you will, stands for twisted pair, amongst other things. But you can see that if you need a greater immunity to electromagnetic interference, that there will also be a foil shielding around these, all of these conductors, and that increases, right, increases even more the immunity of this cable to electromagnetic interference. Now, it's not completely immune to it. Now, let's just understand that. And you could have some that go even farther than that, expensive cables that not only put a shield around all of the conductors, but actually shield each individual pair. All right, so where would you maybe need something that has that so much shielding? Well, I want you to think about it. If you can't get around using other media that we're going to talk about, something like fiber optic media, and you have to use copper media, but let's say you're running it next to an elevator shaft. Let's say you're running it next to a HVAC system, heating, ventilation, and AC that gives off a lot of electromagnetic interference, right? Well, in those implementations, you're going to want to be running shielded twisted pair, right, because of the resiliency to magnetic interference. Now, I will tell you, though, that's not always the case. Sometimes when you talk about higher speeds and specifications, sometimes they need the shielding because to get these massive speeds, 10 gigs and beyond, some even today can go up to 40 gigs in very short runs, they do not do well with any unwanted signal, which is just interference. So you might be required according to the standard. So, how do we make connections? All right, well, we make connections to these twisted pairs right here through something known as an RJ45 jack, right? The RJ45 jack stands for Registered Jack 45, and there's a whole bunch of different standards, ladies and gentlemen, but the big one about this is to also know that it's called an 8P8C connector, because there are 8 copper conductors, if you will, right, pins, and what we do is we wire our connections into the back. We wire these conductors into the back of the RJ45 jack, and then we take a cable crimper, and what we do is we tighten it down. All right, and when we crimp it down, it essentially adheres this connector right to the end of this cable. And that's important. So the RJ45 jack, I want you to know, RJ45 is the registered jack, or the way that we terminate our Ethernet cables.
Yeah, this is important, and the reason why is because just about every device that's going to connect to a network of some sort, whether it's networking equipment or even on the back of your computer, it will accept that jack that has now been standardized throughout the entire industry. So if you try and actually plug a cable in that doesn't have that jack, well, whatever device you're trying to plug it in there is not going to accept it. So pretty much the entire industry has standardized around this, which makes it easy because it means you don't have to carry around a bunch of different types of connectors in the end. And the other thing that I want you to actually pay attention to as well, you may hear the term terminating a cable. When you put a connector on the end of a cable like what Wes just showed you, you are terminating that cable so it can now be plugged into something else. So all those are actually kind of weird terminologies, but you'll hear them throughout the industry called different things. So make sure you actually know that too.
I like that, Ronnie, that you said that, because you and I, you know, if you're first getting into this industry, what would we call it? Well, we're applying a connector to the end of it. But that termination standard, again, it's some of the jargon that you should be aware of, and don't let it confuse you if you hear somebody refer to that. Now, one of the things that we've been talking about is the internal makeups of the cable. We've talked about its conductors and what the twists do, how many conductors you have, as well as, like Ronnie mentioned, the termination of the cable. How do we put a connectivity jack on the end of it? Now what I'd like to do is I'd like to focus in, everyone here, on the jacketing itself. So jacketing there's nothing really fancy about it, doesn't really look like much. We've got different colors and sometimes for different specifications and stuff. But it is important to understand that there's 2 different types of jacketing. There's what is known as PVC jacketing, and there's what's known as plenum. I'm going to say there's what's known as plenum and non-plenum, all right? So let's talk about non-plenum, and I know I'm doing these a little bit backwards because you have cables like this and really cables like this, and probably most of the cat cables that I have, or the twisted pair cables, I should say, that I have in front of me that are using the PVC connector. And again, there's nothing really to see here because what is PVC? Polyvinyl chloride. PVC jacketing, we have issues with this. PVC jacketing can be used for things like drop cables that are not in plenum spaces. Big technical jargon for open air handling spaces with HVAC systems between your walls, right? Now, if these basic non-plenum PVC-based jacketing were to ever burn, it would give off a toxic gas. And the other thing I want you to notice here about this cable is very easy to work with, right? And there's some space. You can kind of see some space in between those connectors right there. Now that space can allow air to pass through it. All right, and if you need to run cabling that will pass fire code and fire inspections when burnt, does not give off of toxic gas, and the outer jacket is really tightly wrapped to the central copper conductors, then that's where plenum comes in. Plenum does not give off of toxic gas, and it's very stiff cabling to work with, Ronnie. It's kind of frozen, if you will. You don't have to go into the frigid northeast to have a hard time working with these cables. Because of that, it's what's going to be used inside of air handling spaces in your structured cabling. So plenum, something for fire code, non-toxic when burnt, very tight fitting, if you will, to those copper conductors used in the air handling or plenum spaces, as they call it. PVC is commonly called non-plenum, and that's going to be used for things like drop cables, those non-plenum or non-HVAC kind of implementations today.
All right, so Wes, if I just find any network cable that's out there, that should actually be able to work for anything I want, right?
Well, you would think so. For instance, we look at these cables and there really doesn't look like there's much difference to them. But unfortunately, that's not the case. There's a little organization called TIA. They used to be called TIA-EA, but EA doesn't exist anymore. TIA is the Telecommunication Industry Association, and they are the company, the standards body, if you will, that's formally endorsed by the American National Standards Institute that defines the electrical capabilities of these cables, and they do that through specifications. And some of the specs that we have to talk about are what are known as CAT cables. And I can tell you, ladies and gentlemen, this is one of these type of subjects that if you are in some kind of, you're going to sit the certification exam, then you're going to need to know these specifications. But you also have to know, is it okay if we just, we recommend a Cat 5e cable over maybe a Cat 6a cable? And what does that even mean? So TIA formally defines them under what are known as category standards, and a lot of times we just abbreviate that, and we call them CAT cables, right? Well, the categories have been around for a very long time. And some of the ones that you used to have to know would be starting with what was known as a Cat 3 cable, and the Cat 3 cable was what was known as one of the earlier and earliest Ethernet twisted pair cablings. But today, there are just a few of them that I need you to be aware of for the certification exam, and that's Cat 5, Cat 5e, Cat 6, and Cat 6a. Now, that's a mouthful of specifications. Let's talk a little bit about those. Cat 5, that is what is known as fast Ethernet, and it allows 100 megabit transfer speeds. All right, you have then what is known as Cat 5e, and Cat 5e came out, it's an enhanced, Cat 5e, if you will, Cat 5 enhanced, and there was a real big push towards gigabit Ethernet. But we weren't quite there yet, and Cat 5e could support gigabit Ethernet speeds at very short distances, so they called it gigabit Ethernet, although technically it's rated for about 350 megabits per second sustain. And I want you to know that. I want you to know what the name is. Cat 5, fast Ethernet, Cat 5e, gigabit Ethernet. But then we get into Cat 6, all right? And when we look at Cat 6 is the first true standardized gigabit speeds, and here's the kicker, out to what's known as 100-meter cable length. All twisted pair implementations, to make it easier for some of your flashcards, have a maximum transmission distance of 100 meters or 328 feet. Anything past that, and you get what's known as signal degradation, it just deteriorates the signal. You can run into things like timing issues. So that's the specification regardless of what CAT cables we're talking about. When Cat 6 came out, they said this is going to be the first cable that it is endorsed for gigabit speeds at the full distance of the cable. But then, as time progressed, we started getting into 10 gigabit networks. Well, believe it or not, Cat 6 can support a 10 gigabit transmission distance, but not at 100 meters. It greatly reduces it to about 55 meters. And that's where Cat 6 augmented, Cat 6a comes into play, because Cat 6a is the formal TIA specification that will allow you to make and hit a 10 gigabit Ethernet network at a full 100 meters. All right. Now, there's other ones out there that you don't really have to worry about. You might come across a Cat 7 once in a while. That's not formally endorsed by TIA, and that was because when they came out with that cable, they did not want to go with the traditional RJ45 jack. They wanted some special jack to go along with that. So if you see that out there, it's not officially endorsed, but I definitely would know 5, 5E, 6, and 6A. Know their names like we've told you about. Fast Ethernet, Gigabit Ethernet, know what the transmission speeds are, as well as the maximum distance, and that can always help you out because regardless of the CAT implementation or the Ethernet implementation, the maximum transmission distance is always going to be 100 meters.
Yeah, this idea of actually understanding those specifications, we can clearly see a lot of times on the actual cable jacketing itself, and that will allow us to at least be able to, when we pick up a cable, to know what we're actually trying to get to, right?
Thank you, Ronnie. You know, that's a great reminder, and Ronnie's absolutely right. Let me show you what Ronnie's talking about right here in the front of that cable, just past the mono price. You can see Cat 6. Right, just barely right there. So that lets me know that this is a Cat 6 cable. You can also see this on your other cables. You can see Cat 5, Cat 5E, if you will, maybe even 6A. So it's really easy to identify the cabling based on its shielding. Also, if you have to purchase these products, remember that if you get a spool of these, the twisted pair cabling that you're going to be making your own cables, you can also identify it on the spool as well, too.
Yeah, now, when we actually create these cables, though, you said that there's 8 different conductors. There has to be some sort of specification to actually being able to terminate them correctly, or is the cable just going to work no matter how we terminate them?
Yeah, Ronnie, you know, we would say that it'd be the wild, wild west, but the problem is when you have these long cable runs, you need to ensure that you are going to wire them into the back of the RJ45 jacks consistently. And that's why TIA also has a standard out there that's called the 568 commercial building standard, and a subset of that is how we essentially wire these jacks, right? So we've got our twisted pair implementation, we've got a series of color coding here, and we've got our RJ45 jack, and we need to make sure that we wire the arrangement on this side the same on this side. All right, so there are 2 standards that I want you to be aware of. There's what is known as an 568A, and there's 568B. All right, and all these do is they define how you arrange the wiring, the conductors, and then crimp them into the back of the cabling. All right, now, a lot of times you'll see that cabling like this will be a 568B wiring scheme, if you will. It's important for you to know if you're sitting a certification exam that if I have what's known as, take any one of the standards, 568A on one side, 568A on the other side, or 568B on one side, 568B on the other. That becomes what's known as a straight-through cable because they are identically wired on each side. All right, and pins 1 and 2 are what we call your transmit pins. Pins 6 and 3 within, or conductor, if you will, 6 and 3 are the receive pins. And if they match pins 1 and 2, wiring matches pins 1 and 2 on this side, then it's what's known as a straight-through cable. And these were commonly used to plug into the back of your workstations, into the wall plates, the wall jacks on the wall there. Now, if I take one of those standards, 568A on this side and 568B on this standard on this side, then what I'm doing is internally I'm taking pins 1 and 2 and pins 3 and 6, and I'm crossing them over from one side of the cable to the next. That becomes a crossover cable. And these are very, very good. When you need to test a point-to-point connection, let's say between 2 laptops and you don't want to put a switch in the middle, a connectivity device in the middle of them, then you can directly plug these into the network adapters and they can communicate back and forth and they don't need a connectivity device. Another practical application of a crossover cable is when you need to do maybe some configurations on an IP camera and you don't want to plug them into a connectivity device. You want to go from the port on your laptop straight into the back of the IP camera. If you have 568A on one side and B on the other side, you've now crossed those cables, creating a point-to-point connection that you no longer need a connectivity device for.
Right, so that actually is something that's very helpful that you may have to correct if somehow that connector gets crushed underneath the wheel of a desk chair. Somebody walks on it and crushes it. So you repairing that cable, understanding the standards on both sides is going to be very helpful as you put that particular cable back together. Now, Wes, this is not the only type of copper cabling that we have. We still need to talk about coaxial cable, right?
That's right. Coaxial cables are a little bit different than our twisted pair. And why do we say that? Well, a coaxial cable, such as like, for instance, the one I have, they talk about it is a single, and let's journey right in here. You can see just a single copper post right there in the middle. That's the coaxial cable. All right, and it's important to understand that when we have coaxial cable, we only have a single copper connector. And then the way the coaxial cable is made up of is we have that centralized copper conductor, and then what we have is a non-electric shielding around that cabling, and then a braided shielding around that to help reduce the electromagnetic interference. And then finally we have a jacket around the outside of these. Now, when we look at the coaxial cabling, there are two different standards that I want you to be aware of. One standard that's been around for a very long time, and it's still used today, and the other one, like this one that I have here, that is more of a common standard, or more becoming more of the commonality. All right, and what I'm talking about is RG59 and RG6. These two cable types are the coaxial cable types that we pretty much are using today. And for instance, and the same thing goes with these, Ronnie. You can see the RG59. It's a little bit different than RJ. RG is radio grade. It goes back to an old military standard that's really not used anymore, but they still follow some of the numbering. This one right here, this thinner one, this is what's known as an RG59 cable. And what I'd like to do is kind of just put these two cables side by side, and you can see this is an RG6 cable. This RG6 cable is a lot thicker today. All right, so these are the two cables that we used to use them in networking. Today, more than anything, they're not really used in networking, but what they are used for, and you can ask any one of our directors back here that's connected any coaxial cable to one of our cameras, it's heavily used in AV, audio and video production here. So that's your RG59 cable, and that's your RG6 cable. These are two coaxial cables that I would be able to identify today. And the connectors that they use are what are known as BNC connectors. So if we look right here, you can see that there's this little sleeve here, and it's kind of a twist to lock type connector. The outside kind of twists and it locks. And I'm going to grab the RG59 because it's a little easier to use. All right, and this is what's known as a T connector. And that's how we make terminations, if you will, on or split our coaxial cables. The BNC connector is one of the most common coaxial termination methods today. All right, it's a standard that's been around for a very long time. I think it's Bayonet Neil Konkelman is one of the many names that it's accredited towards. These just happen to be T connectors, and these can essentially split a coaxial communication into three different signals. You have things like this where it's an L bracket. It's still a BNC connector that goes to a 45. And again, kind of show you here, it is a twist to lock implementation. All right, so those are the connectors. Now, there's one other connector that I don't have up there, but I would encourage any of you that has a cable internet connection, if you're using cable television, and that's the F connector. The F connector is typically what you see goes back into the back of your modems. These are the two most prevalent copper media types that we have today, and it is something I would be aware of and know the specifications that we've talked about for your certification exams, as well as if you're in a support role so that you can make the right decisions if people come to you for that.
Now, with copper media, no matter what size it is subject to things like the electromagnetic interference and radio frequency interference. But we want to talk about fiber optic as well, because we're starting to see more and more of that in the world, right?
That's right. Fiber optics, you know, if it would have been 10 or 15 years ago, we wouldn't really be talking about fiber optics in anything except for just enterprise level networks today. But the price of fiber optic communications has kind of come down as the technologies become more prevalent, but there are a couple of cables that I want you to be able to be aware of. So when we talk about fiber optic type cables, we have a couple of varieties, all right? We have what's known as single mode fiber, and we have what's known as multi-mode fiber. When we talk about single mode fiber cabling, if you will, sometimes abbreviated SMF, is the longest what we call bounded transmission media on the planet. What I mean by being bounded, right, we're still bounded to a physical cable. These can run kilometers. All right, and that's due to how the signal's propagated down a single mode fiber cable, if you will. It has a jacketing. It has a cladding that's about 125 microns thick, and then the core that's inside of that, it's around 9 microns thick. And again, that's an absolute just amazing. We're talking about 9 millionths, I believe, of a meter here when we say microns. Very, very, very small. And so I want you to know that, right? A very small, concentrated 9-micron core, and the light source is a laser, essentially shot down like a rifle shot down through the center of this core. The core is highly concentrated, so it has the farthest signal propagation. The other one is what is known as multi-mode fiber, and multi-mode fiber are called MMF. You will see has a little bit different of the variation. The cladding is still 125 microns in diameter, but the cores can either be 50 or they can be 62.5 microns, and what they do is they actually refract the light, bouncing it off the cladding to propagate the signal, if you will, down that cable to the end. Now, due to the fact that the tolerances in single mode are so tight, you get a farther signal propagation. Due to the fact that the cores are not as concentrated in multi-mode fiber, you do not get the same amount of distance out of a multi-mode fiber cable that you would a single mode cable too. Now, a couple of connections that I would be aware of. We've actually got both of them on one cable. There is an older one, and that older one is what is known as a subscriber connector. And we can kind of take a look at this here. The subscriber connectors, in fact, Ronnie, the two connectors that they want, they're both on this cable. Right here is what's known as an SC connector, right? That's a subscriber connector. And what we have here is we actually have two fibers. This is what's known as a duplexing cable because it allows us to send and receive over two pairs of fibers, if you will. Now, the other one that you see on this cable as well is the newer. This is actually a compatibility cable with older standards. And the newer standard here is what's known as the Lucent connector. That's the LC connector. You can see that it's about half the size, and that's because port density, the amount of ports you have on a single connectivity blade within, like for instance, a switch, they've gotten smaller and smaller. And because of that, we can fit twice as many of these into a connectivity device as we could the earlier subscriber connector. You can see they're about double the size. Now, staying right there, you can see a cable that is a little bit more modern, right? And it has two of the Lucent connectors, or Lucent, I know I keep saying Lucent, but it's Lucent connectors, LC connector, if you will. And if you're in a certification exam, one of the things that I usually admonish our students for is that if you have to remember which one's which, the Lucent connector, I want you to think little connector. It's half the size of the subscriber connector. These are the fiber optic cables, and the connectors that we use to terminate them, like you heard Ronnie say in an earlier statement. Everybody out there, if you're sitting your certification exam, I would definitely know these specifications, make flashcards, and if you're in a support role, I would also know the specifications so that if somebody comes to you asking you these questions, you can make the right decisions.
Thank you for watching IT Pro TV.